Hello everyone, and welcome to this video on using Python in Kestra. Kestra is very flexible in that it is language agnostic, meaning it doesn't really care what language you want to program in. If you can Dockerize it and make a container, you can then use that code in Kestra. Also, you could use scripting languages like JavaScript, Bash scripting, or Python, and run that directly on Kestra and not put that in a container. In this video, though, we will be focusing on Python to get you started and get kind of a feel of how to use that in your tasks and flows. So, jumping right in, ways to use Python in Kestra. Well, there are two plugins that we'll use. The first one I'd like to point out is Script, where you write your code directly in your task, and then the Python script plugin execute that code. There's also Command, where you can put your code in a file in a number of different places, and then point your task at that code and have it execute. So ways to run Python, which I've already stated, but just to recap, in a Docker container, so that will spin a Docker container and execute your code in that container. There's also process, which we'll see that configuration here in just a few, where if you did not mount Docker into Kestra and you're running it in Docker, you can still run your Python code by using process. Sounds a little confusing, but I'll point that out when we get there. And last but not least, where to store your Python code. You can kind of use your imagination on this one. You can store it in namespace files. You can store it in a mounted directory if you're running Kestra in Docker. You could put it in GitHub. Say you have a flow and you have a task that pulls that code down, and then a subsequent task that takes that code and executes it. So without further ado, let's jump right into some code so we can see this in action. All right. Here we have the Kestra Docker Compose file. And if you're not familiar with that, you haven't played with it before, it's really easy to find. You just open up a browser and we'll just look for Kestra Docker Compose. Go to the Kestra GitHub and you just need to copy and paste that. Name it docker-compose.yaml and Docker Compose up. And I will make this a little bit bigger here and just run Docker Compose -d because I necessarily want to see the output. If this is your first time pulling the Kestra images, it might take about 5-10 minutes. So not too bad, but just be aware. If it seems like it's taking a while, there's nothing wrong. It is just kind of a large pull. But since I've run this several times already, that came up very quickly. And just need to go to localhost 8080. And here we are. A few things I'll change real quick. Go to settings, the dark theme better, easier on the eyes maybe. And I will try to make this bigger so it's easier to see. And if we go to flows, you can see I do have a few flows defined already. Hard to read the names with it that big, but I just wrote these ahead of time, so I didn't use up a bunch of time having you just watch me copy and paste these commands. But what we have here is a Python command example, a Python script example, and a Python local script example. Probably do that last. We'll start with Python script, as that seems pretty logical to me. And we'll actually go to the editor, as that gives us a little more space to see. Have some pop-ups here. And let's see, make that a little more readable. All right. So this is our flow. You see it over here under the flows directory, and the flow is just called Python command. The namespace is Python demo, and we can also see that here on the left-hand side. And the plugin that we're using is going to be the scripts.python.commands. Again, if you wanted to use this, you could just do Kestra Python, and the first search result will take you to links where you have examples of both commands and you could just copy and paste those, as well as look at the blueprints here. There we are. And actually, I wanted to start with these scripts, as I think that's a little simpler because you're not using a script file. You are defining your script in the task itself. As you can see, I have some things commented out here. This over. There we go. So this flow is Python script in the same namespace, Python demo. The tasks, the first one, well, the only one, is demo script, and it is the Python script plugin. You can use the control whack to comment, uncomment, control S to save. Kind of a nice feature to have the code editor built in here. If we go down, you see I have the Docker property commented out, as well as the before command. And what we can do is we can actually do runner process, which will not use a container. It will actually execute it on the container that's running Kestra. And we can go ahead and execute that. It should go relatively quickly. And if we look, it just prints out hello. And if we go back, we can see all it does is print hello. So that's going to show up in our logs. Could also do something like for I and range 0 to 5, and we could print that. Control S to save that and execute. And again, 0, 1, 2, 3, 4. Does not go up to the 5 in the range function in Python, if you're wondering why that wasn't printed. And let's see, can I make this? Let me zoom out just a little bit for readability. So, could do is I could uncomment, or I could comment the runner process and uncomment the Docker. And this is actually going to pull an image from Kestra that they maintain, PyData latest. And then it's going to feed that script in. So we can go ahead and execute that. Control S to save. There we go. It shouldn't complain. We didn't see this when we used the runner process. This is pulling the image, and then we can see what command it is feeding into the Docker container. So it's using the shell, -C for command Python, and then because it's stateless, it's creating a temporary file for our Python script, executing that, and then we do have the output. And one thing to be aware of is the default behavior in Kestra is going to be to run it in a Docker container. So if we go back to edit our flow and say I forgot to put in Docker, and I forgot to put in runner. I don't know, I'm just forgetful or fat fingering today, and go to execute that. We are going to be waiting a little bit longer, but it knows it's using the Python plugin. So by default, it's saying, hey, I don't have a container, but I need a container to run this script. So it's going to go out and grab Python latest, use that instead of a specified Docker container, and then execute the script we defined in our flow in that container. And also, some other features to be aware of before commands. So say you want to pip install pandas, high arrow, trying to think of some typical packages used in data engineering or that are just commonly used at the moment. So here, well, actually, let's do this. Let's go and we will comment that out. And I'm going to say import pandas as PD, save that and execute. We have an error. No module named pandas, because the Python container latest, not too familiar with it, but probably doesn't have a lot of extras installed, if any, so pandas is not included. If we then go back to our flow and just say, before the commands, go ahead and pip install pandas. Don't really need the pi arrow there. And rid of those for readability. Pandas does take a moment or two to pip install. Been a while since I had to do that. So that's probably why you're seeing such a lag here. All right. Image pulled. And we can see that it executed that pip install before it went ahead and ran our script. And we didn't have anything else, but we do have, if you've installed pandas, you've probably seen all this. It's where it's collecting all the dependencies and installing them, and then we have that package available to use. Again, very powerful, because say, I'm trying to think of a scenario, you have a task in your flow that needs requests 1.12, and then for some reason a subsequent task needs requests 2.15. Well, you could install those versions in each task and keep those isolated. And you could also do output file, output files like that. And this is going to be something that you can regex, and I think I need a dash there. Yes. And I'm just going to go ahead and call this test.text. And we're going to write to it. We'll just write lines. Hello from inside a container. And we can save that and execute. I could have gotten rid of the for command pip install pandas and probably sped this up quite a bit. All right. We see pretty much the same thing. Let's see if anything's different here at the end. But we do have captured one output. So now if we go and go ahead and download that, hello from inside a container. So we can then write out files. You could also pass input files to it as well. You could just do input files like that. And then depending on if it's something dynamic, say the task before this is task before dot task.uri. And you could do something like that to pass in an input file. Not sure what that syntax is. Oh, probably that. Well, I won't dwell on that, but just know you can pass in files like that. And yeah, I think that about covers the. So let's move over to the command. Not logs, flows. There we go. Actually, I can go back to the editor. Probably easiest. And here we have our Python demo namespace. And we want Python command. Okay. So here we are passing in a file with our Python code that's going to be executed. So it's pretty familiar, looks very similar to the Python scripts. You see I have runner process here again, but I do have namespace files enabled true. Why do I have that? Because here is our Python demo namespace. And in that namespace, I have a directory called scripts and a file called hello.py. Because the tasks and flows are isolated and stateless, more or less, you do not really need to interact with files on the file system, but this is a way of explicitly letting you interact with those files in your namespace. Might help you stay organized. I'm going to go ahead and comment that line out. And I already saw output files, so I will comment that out as well. Control S to save, and we'll execute that. What happened there? So you see, this is the command it tried to execute, but Python can't open file temp where it was looking for it. So this is the directory where our task is running. Makes a temporary directory for persisting, well, not persisting data, I should say, but any files that need to maybe get written out, read back in while the task is running. And then when the task is done, that directory, all those files are gone. And that's where it's looking for it by default. But if we go back and we say namespace files and set enabled to true, and we will execute that again. Let me go ahead and check the contents of that script, because I think I may have written that to write out a file. We can change that real quick. Oh, it just prints hello. I'm not too creative today, so hello from the namespace. And we'll go ahead and execute that again. Very quick execution, and hello from the namespace. Okay. So let's see other places that we could store our scripts uh, in order to execute them. So if we go back here to the editor, we could even say I have a lot of flows in this namespace and I want to have a very quick way to look at those scripts and say, those scripts go with this flow, those scripts go with that flow. If something breaks, I know where to look for this script. So we were running Python command. So let me go ahead and rename this. I'm going to call this command scripts. And back to command. It's that one. And can update that to command scripts. Notice with the command, we do specify Python. Just be aware, if you don't have that, you will most likely get some errors. And we can show that error real quick, just in case you run into it. So it's running sh and -c for command. Well, you're not telling it to use Python to run that script. So just be aware in case you see that error. Might save you a few minutes of looking around, scratching your head. And go ahead and save that. Execute. And indeed, we have hello from the namespace. Feel like I should have written space a few times after that. Sounds like something where you'd say hello from the namespace, space. Just my... Okay, back to the editor. Other places where we could have our script files. Let's go ahead and bring Docker down real quick. Docker compose down. Okay. Well, we can see that we're mounting volumes into Kestra. This is going to be the data for Kestra itself. That's what allows our flows to be persisted. When we bring it down, bring it back up, that data is in this Docker volume. So that will be there. The other one, mounting Docker, that is what allows Kestra to run the containers in Kestra, as we saw, where it pulls the images. And then it also does need temp directory. I believe that is used to build the intermediate stages, building the images. But we can go ahead and mount another directory. So I'll just use /, meaning the current directory I'm in, Kestra Python, and I'll just say Python scripts. And where do I want to mount that? I'm going to go to app Python scripts. Go ahead and save that. And I will need to make a new folder and call that Python scripts. And inside there, let's see. Oh, I wish I could think of something more interesting, but test.py. Hello from a local machine. Go ahead and save that. And we'll go ahead and just up arrow twice to bring Docker Compose back up. And let's go back and refresh. Might take a moment here to come up. All right. Close that out. And if we come back here, I'm going to say app Python scripts. Go ahead and save that and execute it. Oh, we have an error. App Python scripts. So I believe that's because I named my script test.py. Let's save that and execute it again. And hello from the local machine. And because that's a bind mount, that is actually shared data, of course, but it's kind of nifty because it's real time. You make changes in one area, it shows up in the other. And I'll show you what I mean. If I just come back here and say, well, now this is different. Go ahead and save that. And I'm going to execute this again. And you see the changes that we have made to that file in the directory that is mounted into Kestra. Those changes have been updated, and that is seen inside. Okay, let's see if we can do something a little more interesting here. I'm going to go back to the editor and we'll go ahead and do command. This time, well, actually, let's do a script. And I'm going to go ahead and I will use the PyData image from Kestra, which comes with some already installed packages, PyArrow, Pandas. If I come out here, you can kind of see what's installed: SQL Alchemy, OpenAI. So that's a pre-built image that's got a lot of stuff that we can use right out of the box. So switching back here, I don't need to install Pandas. I don't need to run as process. I will need input file, but for that, let me go ahead and I'll leave that for the moment. And in another window here, I'm just going to go to Kestra and go to the blueprints. And I want to download a file. And the one I'm interested in here, yeah, I guess that pretty much has everything we need already, but I want to just straight download. I could also have just gone out and done Kestra download file, and that should come up. There we go. And I don't think headers is required. Go ahead and copy that. And back in our script, we are going to put this task first and line that up. It's going to need a space. Give ourselves some room so we can differentiate. Doesn't like the alignment there. Go. And this one probably needs to move out. All right, that looks good. Control S to save that. I'm going to move that over, give us a little more space. And we can go ahead and use the usual New York taxi data And all I want to do is show how you could use this in a flow, have a Python task that does maybe some data manipulation, maybe does a little bit of analysis on file. I would say maybe removing columns, or if you don't rows of data where, say, everything but one column is blank, you could remove those before pushing it up to something like S3 or Google Cloud Storage, just to save yourself some money on storage costs. And we can just scroll down. I think for hire vehicle is usually the smallest of these, so I'm just going to use that. So hopefully it comes down real quick. And Control V to paste that in. And kind of curious. I'm just going to run that without the headers property and see if that works. Comment out this, save it, just because I want to see the download. And we can execute. And while that's going, I'm going to grab the data dictionary, just because I want the column names to do a quick manipulation on that. And let's see here. All right, that seems to have worked. We'll look at the outputs. All right, it is 10.8 megs. So let's go back to our flow and do something with. So here, just going to uncomment and going to use PyData latest, and I will make a data frame, and that is going to be pd.read parquet, and that is going to be outputs dot task ID URI. Do I need a second set of single quotes? Let's execute and find out. Well, it helps if you import the package that you would like to use. So, not sure which key that was. I thought that was enter. There we go. Import pandas as PD. Go ahead and save that and execute. While that's running, let's go ahead and go back to Kestra Python. And let's see if we do need to specify the input file. I believe it will be able to see the output from the previous task, but I just want to be sure. Okay, so we could make that a friendlier name. Using the input files would kind of map that to a different name, meaning you could grab that URI variable and then pass it in as a friendlier name. And let's see if that succeeded. I did. So go back. For some reason, the enter key by my number pad wants to be a hotkey at the moment. So we can just do print df shape, Control S to save that. Let's execute that again. And even though everything was green, It's a very simple one line of code. So I'm pretty sure it's working correctly, but that would just verify that we do have a data frame that has 1,114,320 rows and 7 columns. What we could do is, I guess we could do a little detour here and show the input files. And then I believe that spacing needs to be moved. And we're just going to make that FHV parquet. And what is that going to be? It is going to be the output of the previous task. And then you can go ahead. I think it helps if I spell it right. It would probably interpret that has a parquet file correctly either way. Let's just make sure. Control S to save. We'll execute that. And indeed, with the friendlier name, we can use that as well. And I guess it's a nice feature. I guess it's just preference. So you could either dynamically grab it from the previous task, or you could define it as a friendly name and just have that defined as an input. Okay, so one last thing. Let's say we want to do just 2 columns and make a CSV. For some reason, we only care about pickup date time and the drop-off date time. And let's do 2 CSV, pickup, drop-off.csv. And rather than looking for text files, we're going to look for CSV files. And what did I do wrong? Let's see. I think it does not like the double brackets, but that's okay, because that is good reason to have flexibility of being able to do either the scripts or the command. So we can just flip this over to a command real quick. So actually I can modify this. I'll do commands and let's see here. Go ahead. Script, I'll do command. And underneath there, I will just do Python trim columns.py. Let's see here. Oh, I think that should be commands. And let's see. We also need before command. Oh, no, we don't. Because we're using the image from Kestra, it has pandas inside, so we won't need to pip install that. We go back to the editor here. Just need to here and file. I call that trim columns.py. We'll just paste that in here. And I won't take the detour, but thinking about it just at this moment, this is a good reason to define those input files. I don't believe you could use the double curly brackets output of the previous task in your script. So another reason where the input files would come in handy. So we have trim columns, and we're going to need to tell it command scripts. And actually, let's give ourselves some output here. We can do f string and just say shape before is dot shape, and not sure why that was indented, but I just made sure to move that over. And actually make a new data frame just so we can get the shape of it after. And shape after trim. Okay. That looks good. Go ahead and execute. Command scripts trim columns. Oh, did I forget to enable the namespace file? Command scripts. Sure why that reverted. There we go. Namespace files enabled is true. So then we'll be able to grab our script file, and let's try that. Let's see. Does not seem to like the column names that we gave it. So let's go ahead and we'll go back to our editor. And this time, rather than parsing it, we'll just have it spit out the column names just so we can verify. My instinct says they're probably all lowercase, and just the documentation here does not reflect. Let's find out. So I'm just going to comment those lines and then just print df.columns. Go ahead and save that. And let's see. I think I confused myself because I turned the Python scripts file into Python command plugin for the task. Okay. All right. Oh, that's nice. I was worried it was truncated. It's just on a new line, and indeed, that's all lowercase. This one just has a weird O capitalized in drop off. So let's go ahead and update those. And to modify our script here. Now we can just go ahead and delete that print of the column names. And all lowercase except for that very oddly capitalized O. And save that. And we'll try this one more time. All right. So we can see here the shape after the trim. Same amount of rows, which is to be expected. We just went from 7 columns to 2, and we see that reflected here. Again, we do have the output file. So say we want to go ahead and load that up into S3, load that into GCP. We would just make a subsequent task to do that. And now we have trimmed out some of the data, save ourselves some storage costs. Now, one last thing I would like to show before this video concludes would be you can also have a task that pulls down your Python script from, say, GitHub, and then executes that. So we can see that real. If we go ahead, and this is actually going to use a working directory. Might make another video just describing that. You can go out and see the documentation. Working directory, Kestra. But that just allows any files in a task to be seen by the other tasks in the flow without having to use the outputs dot task name or dot task name dot URI or files, things like that. So in this case, it's going to use a working directory so it can see the files in the subsequent task. It's going to clone this repository, and then it is going to, in the PyData container created by Kestra, it's going to install Faker and then run these scripts and make an out file. And we can just go ahead and we will copy that. We probably could have grabbed it from blueprints in Kestra. It's probably in there as well. We can just do it like this. A moment to load. All right. Want a new file. Pull. And not .py, .yml. And another nice thing here is because we are in the Python demo namespace, it's going to put that namespace in for us, and the ID is going to be the same as the name of the file. Let's see. We can just highlight that. I think I missed grabbing the ID. Let me just could have just typed that and fix the indentation again because it looks like I'm too far in. Save that. And go ahead and just run it. Again, it's going to pull down this repository from Kestra on Git, and then it's going to look for these scripts in there and then run them. And it will be able to see those in the task that runs the scripts because it's running in a working directory task. All right. Go ahead and run that. Working directory is going to run the entire time. Let's see. Python cannot open file. Okay, scripts, ETL script. Let's see what's going on with the flow. Pulling this repository, and then repository under scripts. And take a look at it. Okay, I don't see a scripts directory. Do you see an examples directory? Scripts. Okay, and the files are there. So looks like just needs to do examples. Examples. We'll save that. And let's execute that again. Okay. And you see that all ran successfully. And if we look, we should have an output orders.csv, which we saw here in the out files. All right. I think that should be enough to get you going with using Python in Kestra. Again, the two main ways are commands where you pass in a file with your code, whether it be in the namespace files, pulling down from GitHub, or from a mounted directory. There is also scripts where you can actually write the code and define it right there in your flow file in the task itself. So lots of different ways you can kind of twist it around, spin it, mold it to your needs. And as always, if you have any questions, run into any issues, go ahead and join the Kestra Slack. If you go to their website, there's the link there. If you're running Kestra locally, you can go here to join the community. And if you like Kestra, don't forget to go over to the GitHub, give the repo a star, lets the devs know you like what they're doing, and to keep up the good work.